Hello everyone, this is our science teacher Tim Martin, and in this video we'll take a look at part 7 of meteorology, continuing with motion in the Earth's atmosphere, looking specifically at breezes. Also, you'll get a chance to meet Surfer Girl and Climber Dude. I want to come back to the idea of convection since that is so vital to understanding the process of wind. Once again in this image, you can see the light emitting radiation. The radiation is being absorbed by the black metal can. As that radiation is absorbed, the energy is converted to heat energy to the can and the surrounding water. That causes the molecules to move faster, which in turn makes them expand. When they expand, they're less dense, and they're less dense, they rise and float. On the right-hand side, near the ice, the reverse is happening as the ice cools the water, causing the molecules to slow down, become more dense, and they sink. This is the driving mechanism or the driving force behind the circulation in the Earth's atmosphere, as we went over in the previous video. But there may be some times when you say, where I live, the wind doesn't always come out of the west. If I live in the westerlies, what's going on? Or maybe if you live in tropical areas, maybe the wind doesn't always come out of the northeast or the southeast. So how are smaller scales affecting this basic overall circulation on our planet? Again, for those of you who are students, I'd encourage you to grab a piece of paper and draw along with some of these simple diagrams. Let's start out by drawing a beach scene. And like I said, I'd introduce you to my friend Surfer Girl. I guess Surfer Girl is not totally necessary for this, but it's always fun to have a little bit of excitement going on in the water. It's important to understand that this first diagram is occurring during the daytime, late in the day, especially in the afternoon. Now, those of you who have had experience down at the beach will know very quickly which area heats up more rapidly, the land surface or the water? That's right, the land is going to heat up much more quickly in the daytime, which means the air over the land will rise and replacement air is going to come off of the water. This is the situation that happens almost every afternoon in coastal environments. We always name wind where it comes from. This is what we call a sea breeze. Doesn't make for the best of surfing conditions. Another way you may be able to observe this happening is for those of you who like to fly kites when you're down at the beach. You'll notice that in the afternoon, the kites always go away from the water, rather different than what happens in the morning. So if this is a sea breeze, let's try another diagram. Again, quick beach scene, but you'll notice that it's a different time. I've got the moon showing here, indicating that it's night or possibly very early in the morning. Again, let's bring Surfer Girl in here for fun. Now you'll probably know that the water will hold its heat much longer than the land surface, which radiates it away very quickly. You'll notice if you go out to the beach in the morning, the sand gets very cool. So if the water retains its heat more, it's likely that there will be rising air over the water, which means the replacement air is going to come from the land. That can help build the swell. As the waves are coming in, the wind coming from the land will build the waves higher. Let's give Surfer Girl a little bit of help. And with a little bit of light on the subject, she can surf in those very early morning hours when the swell is much bigger. You'll often notice that first thing in the morning is when the die-hard surfers are taking advantage of a land breeze, giving a better surface and a stronger curl for the waves. There's another set of possibilities with the wind, so let's try this diagram. Now in this case, some others of my friends, these are ones that I'm a little more familiar with as a climber. I've got Climber Dude. Well, we can't really tell how much the stick figure is a guy or a gal, but we're going to call him Climber Dude. Of course, this one's happening during the day, and another one of the creatures that I'm very familiar with from up in the mountains. Do you recognize this? It's not just any old bird, a big turkey vulture or black vulture. If you notice them, if you've ever watched them fly, they can soar all day, it seems, with hardly flapping their wings. How do they do that? Well, as the sun heats the land's surface, in a valley, that expanding air has nowhere to go but up, and the air along the mountain slopes provides an updraft for those birds to soar with very little effort. This is what's known as a valley breeze. One more diagram. Again, let's come back to our mountain and valley. And you'll notice our climbers have continued their climb, and they better get up to the top because of what's about to happen. Certainly nightfall is on us. And you'll notice the vulture, the buzzard, circling around a bit, but then quickly goes and perches on an old snag. What does the vulture know about the winds? Well, when the sun is gone and the valley starts to cool, there will be an immense amount of contraction, and the air rushing down in the valley can create very strong breezes. These are mountain breezes. The bird knows that it's best to not try flying, and the climbers better get off and top out on their route before the winds pick up. This same principle can work in many different environments. If you're not as familiar with the coast or familiar with the mountains, maybe you live in an urban area. Take a look at this cityscape. Now, San Francisco is right along the water. This image is fairly interesting. Notice on the left side we have the built-up city. Lots of concrete, pavement, and buildings. On the right-hand side is a large forested area. Now think, which one is going to heat up more during the daytime? That's right, it's likely that the city will heat up more. The replacement air will often come from the surrounding area, setting up the city or the country breezes. Microscale breezes can occur on a very small scale. This is my school's campus, and let's take a look at this area of the lacrosse field, soccer field, and parking lot. Of course, the parking lot, covered in asphalt, has a much lower albedo. It'll come as no surprise which area will absorb more energy from the sun. Let's take a look at this from an angle. As that absorbs solar energy, the air over the parking lot will rise. The replacement air? Well, it's likely to come from the fields, creating very small scale breezes. So whether it's happening on a very small scale, such as on our own school's campus, or on a very large scale between the polar regions and the tropical regions of Earth, basic convection is what transports air around our planet. Thanks for watching this video, and in one of the next videos, we'll start adding water into the mix and see how water circulates around in our atmosphere.